Today we'll do one more topic. First, I'll explain you one more topic about the abnormal molecular mass or the molar mass. Because again, the same four formulas we'll get. The colligative properties, won't have factor and all. Okay. First. So this is the last concept of this chapter. Abnormal molecular mass and molar mass. So this is explained by the want of factor in 1886. Okay, so these abnormal in the molecular mass or the molar mass is happening due to the two factors. One is the association, the other one is the dissociation. Okay, or I can say first one is the dissociation, the next one is the association. So whenever you're adding the solute to the solvent, the molecular mass of the solution is changing. Okay, because of the two reasons, either due to the association or due to the dissociation. What is the meaning of dissociation? Dissociation means what? A compound will break into two or more simpler ions. Suppose you have taken KCl. If you dissolve in the water like solvent, so KCl is the solute here and water is the solvent. So when you dissolve the KCl in the water, it will form K plus ions and the Cl minus ions. This is the dissociation of the solute is happening. So due to this dissociation only, abnormalities is causing. Clear this one?
Yes, sir.
Okay. Suppose you're adding the acetic acid in some benzene. Okay. Now we have added the two acetic acids molecules in the benzene, but when it is added to the benzene, it is undergoing the association process. That means two molecules are combining to form single molecule like this. Two molecules when we add it, right? These were combining to form single molecules like this. So this is the association, associating of the molecules. Associating means what? Combining. So due to these factor means there is a cause of abnormalities in the molecular masses. Is it clear?
Yes, sir.
Now can you tell me what is this dotted dot I have drawn here, right? What is this?
Hydrogen bond.
Very good. It is a hydrogen bonding. So due to the hydrogen bonding, association is happening, or during the breaking into the ions, it is a dissociation. Okay, now here how many ions are formed here? Initially there is only one molecule. Now it divided into two ions, right? So n equal to 2. That means what is the meaning of n? Number of ions. Okay, n is the number of ions. If dissociation is 100%, the value of n equal to I, where I is the want of factor. I is a want of factor. Clear this one? Here is same. Initially we have the two molecules, but after association how many happened? Only one molecule is combined, right? So I is equal to 0.5 of 2 to 1. 1 means half. So I is equal to 0.5 here in the case of association. So any doubts in these two?
No, sir.
Just to extend the concept furthermore, this furthermore theory part. Suppose in the dissociation, A compound is there, it is breaking into the form of n number of B ions. So initial concentration is 1 before breakage. So before breakage, there is no product formation, right? So it is taken as 0. Now, at some time t, okay, at some time t, what will happen? Dissociation will happen. So that n number of new ions are formed. How much dissociation is happening is that is a alpha. So alpha is the degree of dissociation. Okay, so alpha is the degree of dissociation. How much of dissociation is happening is that is a n alpha. Here, how much it will decrease? See, product concentration is increasing. Reactant concentration has to decrease, right? As the reaction goes forward. So it will decrease by 1 minus alpha. Is it clear?
Yes, sir.
Then at time t, the total number of moles of solution is how much? The total number of moles of solution is reactants how much? 1 minus alpha. Products how much? N alpha. So if you add these two, you can take alpha as a common so that we'll get n minus 1. This is the total number of moles at time t. Or you can say number of moles after dissociation. Number of moles after dissociation. Okay. So I said Onta factor, right? Before. So that I formula, the Onta factor is equal to total moles after dissociation by total moles before dissociation. Okay. Total moles after dissociation how much? 1 plus n minus 1 into alpha. Before dissociation how much? 1. So you can write I is equal to 1 plus alpha into n minus 1 by 1. That means I is equal to 1 plus alpha into n minus 1. This is very important formula which we'll use in the calculation part. Here, what is the I? Quanta factor. What is alpha? Degree of dissociation and number of ions. Okay, after dissociation. Is it clear the formula? How you got? Is it clear or not?
Sir.
Okay, next we'll go for the association same way. In the association, what is happening? A number of molecules combine into form A power n. Now, initial how much? This is a concentration 1, this is a 0. But at time t, alpha dissociation is association is happening, but n number of atoms are combining. So it is a alpha by n. How much it will decrease? It is 1 minus alpha. Here alpha is a degree of association. Both are same. Wherever the dissociation is happening, you can say degree of dissociation. Wherever the association is happening, we'll say degree of association. Okay. Now total moles after association. 1 minus alpha plus alpha by n, that is equal to 1 minus, or you can take 1 plus, if you take alpha common, that is what will you get here? Can you hear me now? Hello,
Yes, sir.
can you hear me or not?
Yes, sir.
Okay, so total number of moles after association is how much? 1 plus alpha into 1 by n minus 1. So what is the I value? Moles after association to before association. Okay, so I is equal to 1 plus alpha into 1 minus n by 1 by 1. Then what is the I value? But this is the I value. What is the difference between these two formulas? What is the difference between the dissociation and association formulas? Hmm? What is the difference here? Speed. What is the difference between these two formulas? Hello, can you hear me or not?
Sir, n and 1 by n.
Hmm?
One is n and another is 1 by n.
So n in which case we will use, and 1 by n in which case we will use.
For dissociation, n and association 1 by n.
Hmm. In the dissociation, we'll use the n number of ions. In the association, we'll use the 1 by n number of ions. Okay. So this is a one-off factor about the association and the dissociation. We'll do some more sums on this afterwards. But we have studied about the association dissociation, right? So we'll study some more important formulas on that. So one-off factor and its significance. If I equal to 0, there is no association, there is no dissociation, no change. Neither association nor dissociation. I greater than 1, that is a dissociation. I less than 1, that is the association. Okay. So when you solve these problems, if you got I less than 1, that is association. When you get I greater than 1, that is dissociation. If I equal to 0, there is no association, there is no dissociation. Clear? So this is the first one, significance of the I and the Wonta factor. And I said one more formula. I is equal to total number of moles after dissociation or association to total moles before dissociation or the association. Can you understand my handwriting?
Yes, sir.
Any problem?
No, sir.
Next, third one. I is equal to calculated molecular mass to observed molecular mass. That is M calculated to M observed. Okay. Next, fourth one. I is equal to observed colligative property to normal colligative property. Fifth one. We know already RLVP formulas and all, right? Can you tell me what is RLVP formula? Anyone? What is RLVP formula?
P naught minus PS by P naught equal to X.
P naught minus PS by P naught equal to XS solute. But this will be equal to IXS. That's all the difference when you're adding the Wonta factor. Okay. Next, elevation and boiling point. What's the formula?
Delta TB equal to KB into molarity.
Sorry.
So delta TB equal to KB into molarity.
Delta TB equal to KB into molality. Just to add one more I here. That's all the difference. Okay. Same. Depression in freezing point. Delta TF equal to I KFM. Okay. Next, osmotic pressure. Pi is equal to ICRT. That is the osmotic pressure. Here, what is the delta TB? TB minus TP naught. Here, what is delta TF? Fast. What is the delta TF here?
TF minus TF naught.
TF naught minus TF. That is what very important. Relative lowering of vapor pressure first will have the P naught minus PS. Depression in the freezing point also same. These two will have the similarity similar like this. So TF naught minus TF. First tell me what is this TF naught, PF naught and all. Wherever you see some naught, this naught and all, that is a pure component. Whenever there is a knot, there is a pure component. Okay, like a knot. Wherever the knot is coming, that is a pure component of solvent, and without any knot, there is a solution. So these are the formulas with the RLVP. Sorry, with the Vonta factor and all. Now we got clear, right? Idea what is the abnormalities in the molecular mass and all. Or still anybody has any doubts? First, everyone unmute yourself and reply first.
Yes, sir.
Clear, Anjali?
Yes, sir.
Yes, sir.
Diarrhea?
Yes, sir.
Jafar?
Sir, it's a bit confusing for me. Like, I understand how to do it though. So I'll practice a bit. If I have any doubts, can I ask next class?
Sorry, Anjali?
Sir, it's a like I need to I think I need to practice more because I understand the concept and all, like what to use where, but I still have like a bit of confusion. So if I do few problems by myself, I think I'll like get it or I'll understand what I have doubt in. So then can I ask?
Yeah, you can ask anytime, any point of time, because I will give you some more problems also. If that we will get the clear idea. Actually, I didn't explain the theory part of that. Only problematic part, what are the important for the JEE point of view, I'm teaching. Okay, so if you
Okay,
solve
sir.
some more problems, I can understand the application of the formulas, how we will
Yes.
use, where we will use, and all. Okay, you don't worry in that. And this is the end of the chapter also. This is the last topic in the chapter. So we'll do some problems after this. In that, I will tell you how to use these problems and all.
Okay, sir.
Yeah, Jafar, Ram Charan,
Yes,
Varsha,
Yes, sir.
clear? Any doubts?
Clear, sir.
What about Vishwanath? Vishwanath? Prashant, unmute yourself.
yes, sir.
Join just now.
Yes, sir.
You are the new joinee.
Yes, sir.
Okay. You just watch the previous videos and all.
Okay,
You have
sir.
this idea, right? Are you in the moving from class 11th or 12th or already 12th?
Already in 12th, sir.
Already in 12th. Okay, good. So I hope you have this idea of the Vonta factor and all, degree of association, dissociation. Just you forgot little like that. Okay, so we'll solve some more problems on this. Then we'll get the clear idea about this. But only thing is you have to remember these formulas, especially with the colligative properties formula. Which one is a delta TB? Which one is a delta TB not? How to take that one? That is the important thing. So first problem. The freezing point depression of 0.1 molar NaCl, solution of 0.372 degrees Celsius. Okay. So what conclusion would you draw about its molecular state? We know that Kf of water is 1.86 Kelvin kg per mole universe. So this is a question. They are asking whether it is undergoing association or the dissociation. Clear? So whenever the questions are coming on this topic, on the colligative properties, first check it. What is the given data? What is given? Molarity is given, right? So I can take this as a molality. Molality is given. How much? 0.1. Next, the freezing point depression they mentioned, right? So whenever they say freezing point depression, now we have to take total delta TF. So delta TF is given as 0.372 degrees Celsius. And we know already KF value 1.86. So what is the formula we have to use here? Just they are asking about the I value. If you got I less than 1 now, I is equal to 0, there is no association, dissociation. I less than 1, there is association. I greater than 1, that is a dissociation. Then which formula we have to use here? Which formula we have to use here? Delta TF equal to I KF M. So we know already delta TF, its value is 0.372 degrees Celsius is equal to I into KF is how much? 1.86, molality is 0.1. Now can you tell me the I value here by calculation? You just solve it, I will come back within 1 minute, okay? Just tell me what is the I value and tell me what is the dissociation or the association. I will join within 1 minute. Hello,
Yes.
Yes, sir.
for the answer.
So 2.
I value is
2.
2. If I value is 2 now, is it the association or dissociation? If I value is 2, NaCl is associating or dissociating? I greater than 1 the dissociation, right? So we got I value 2, which is I greater than 1. That means NaCl is dissociating into Na plus 1 plus Cl minus 1. Understand now?
Yes, sir.
Next one. One more. Sorry. Calculate the amount of NaCl, that is the electrolyte, which must be added to 1 kg of water, so that freezing point is depressed by 3 Kelvin. Depressed by 3 Kelvin. And Kf of the water is 1.86 Kelvin kg mole inverse. Okay, so what is the answer for this? So first, which formula you have to use this in this case? Which formula we have to use in this case?
So delta TF equal to I KF in M.
Very good. Delta TF is equal to IKFM. Okay, good. Now, so delta TF value is given, right? Already it's the 3 Kelvin, but they are not asking about the I values. Yes or no? They are given this is the NaCl. So NaCl now we know already it will decompose into Na plus 1 ion and the Cl minus 1 ion. That means what is the N value here? 2. Understand? Where N is the number of ions. So N value is 2. If you got N value is the 2 now, how to find the dissociation here? In the case of dissociation, what is the formula? I is equal to
1 plus alpha n minus 1.
1 plus alpha into n minus 1. Good. Here they didn't mention any degree of dissociation, right? That means whenever they didn't mention the alpha, there is a degree of dissociation, nothing now. You have to take it as a 100%. That is a 100%. So 1 plus alpha is only 1. Okay. N is a 2. 2 minus 1 into 1. That means how much? 1 plus 1 is equal to 2, right? Okay. That means I value is equal to N value. How many of you understand this one? When degree of dissociation is 100%, I value is equal to N value. Is it clear? This is not at all related to the problem, but I'm explaining this one. Is it clear now?
Yes, sir.
Any doubts in this? Just we'll use the finally in the next problem onwards, we'll directly write I is equal to N whenever there is a 100% dissociation. If it is less than 100% dissociation, like only 60%, 70%, 90% and all, we'll use the formula. Okay. Now, so we know I value also, we know delta TF value also, but we know molality is equal to what? What is the molality formula? Number of moles of solute by mass of solvent in kgs. So number of moles we know already. Given weight by molecular weight into, if the mass of the solvent is in the grams, we will take numerator 1000. If it is in the kgs now, we'll take just mass of the solvent in the kgs only. That is a molality. Just substitute the value here. Delta TF is equal to I KF weight by molecular weight into mass of solvent in kgs. What they are asking now for us, calculate the amount of NaCl. That means what you have to find out? What you have to find out? You have to find out this one, right? The weight of the solute you have to find out. Understanding? Is it clear up to this or not? Unmute yourself and you can tell the answer. Is it clear or not? Or any confusion? Just expand the formula here. This delta TF equal to IKFM is there, right? I expanded this formula completely in this step. delta TF equal to IKF. Molarity is equal to weight by molecular weight by 1 by mass of solvent in kgs. Now they are asking the amount of solute. So amount of solute means that is a weight. So weight equal to, how we can write? So weight of solute in delta TF equal to delta TF into molecular weight into mass of solvent in kgs by IKF. Substitute the values, you'll get the answer. So we know KF value, delta TF value is 3K. So 3 into molecular weight. Molecular weight of what? NaCl. What is the molecular weight of NaCl? Sodium is 23. Chlorine is 35.5. So 58.5 into mass of solvent is 1 kg of water by I value is 2. It is 1.86. What is the answer? What is the answer? First, how many of you understand the problem? Raise your hands. Got the answer or not? I asked how many of you understand this problem. Raise the hands. Or else I will teach you once again. Okay, at least raise the hands for. I can teach you once again. No problem for me. I will teach you 100 times also. But you tell me first whether you understand or not. Can I teach you once again?
Yes, sir.
Raise the hands. See. So what they're asking here first. 1 minute please. This problem is very important for the board also. So whenever the problem they're asking like this, the amount of NaCl you have to calculate. That is the weight of the solid you have to calculate here. Okay. So weight of the solid they're asking here to calculate. So weight of solid you have to find out. We know already we have to use only delta TF formula. Delta TF equal to I KF M. And molarity formula is what? Given weight by molecular weight into 1 by mass of solvent in kgs. Okay. Here mass of the solvent is what? It is 1 kg water. And what is the molecular weight of NaCl? What is the molecular weight?
58.5.
58.5. So we know molarity is equal to given weight by 58.5 into 1 kg of solvent only, right? Yes or no? So in the place of molarity, we'll substitute this. Given weight by 58.5 into 1. Now, they mentioned clearly like NaCl. We know NaCl is an ionic compound. So when you dissolve the ionic compound in the water, what will happen? It will break into Na plus 1 ion and the Cl minus 1 ion. Clear this one? Yes or no? To dissolve the ionic compound in the water, it will break into ions. Similarly, as an example I am telling, if you dissolve MgCl2 in the water, what you will get? If you dissolve MgCl2 in the water, what you will get? What you will get to dissolve MgCl2 in the water?
Mg plus 2 Cl minus 1.
Mg plus 2 Cl minus 1, right? That means here what is the n value here? One is the Mg plus 2 Cl factor. So n value is equal to 3, right? And they didn't mention anything about the association or the dissociation, whether this is 100% or not. So in that case, I is equal to n. Or if you don't know how to remember this one, use the formula itself directly. Okay, so this is not required for us. We don't want this. Just we got n equal to 2 here because two ions are forming. We know dissociation formula 1 plus n minus 1 into alpha. That means 1 plus 2 minus 1 into 1. So 1 plus 2 minus 1 now, that is a 2. Right? So I equal to 2 we got I equal to 2, we got m value, we got kf value. Pf value also we know. Understand now? Is it clear now? Tell something. So T delta TF equal to 3. I value we got as 2. Kf value we have as 1.86. And M value we got as given weight by 58.5. That means if you want weight only now, what you do 58.5 into 3 by 2 into 1.86. How many of you understand these steps or not? Is it clear now? Hmm. Anjali. Anjali. Diarrhea. What about Divya?
Yes, sir.
Clear.
Yes, sir.
Jafar, Prashant, Sai, Nit,
Yes,
Shruti,
sir.
Varsha, Vanshpanath.
Yes, sir.
Yes, sir.
Okay, just tell me the answer. What is the weight? What is his weight? If you don't want to tell the answer directly, you can keep the message, direct message to me. What is the answer? One 163. Wait a minute. Check it once again. Yeah, Varsha, approximately your answer is correct. The answer is around 47.18. Check it once again, calculation part. The answer is 47.18 actually. Okay. So next one I will give you. So I'll upload this PDF in the Google Classroom today. You can once again go through the problems. The degree of dissociation of Ca NO3 taken twice in a dilute aqueous solution containing 7 grams of salt, where 100 grams of water at 100 degrees Celsius is 70%. If the vapor pressure of water is 100 degrees Celsius, sorry, at 100 degrees Celsius is 760 mm, then calculate the vapor pressure of solution. Then calculate vapor pressure of solution. First, how many of you understand the question? Read the question properly first, everyone. I will write the given data here. You have to solve this sum. That is a homework for you today. Okay. Complete. How many of you understand the question? Did you understand the problem or not first? The degree of dissociation they have mentioned, that is a 70%. So alpha is equal to 70% you have to take. That means 70 by 100. Fine. Next one. Sorry, that is the alpha. Next, if we take solute and if we take other side solvent, the solute, if the vapor pressure of the water at 100 degrees Celsius is 760, that means PS not equal to 760 mm. Then you have to find out for the PS. Don't take it as solute and solvent. Find out the solution. Okay. So you have to find out for the PS. Vapor pressure of the solution you have to find out. So you have to find out the PS. And also, the aqueous solution containing 7 grams of salt. That means weight of solute equal to 7 grams. And CaNO3 they mentioned clearly that molecular weight is 164. CaNO3 taken as the molecular weight is 164. Okay. Next, what is given? We know water. So first, which formula you have to use? PS naught minus PS by PS naught equal to I into XS, right? That means PS naught minus PS by PS naught equal to I into, you have to use Na by Na plus Nb. That is important. Okay. Na by Na plus Nb, you have to use this formula. Just try this formula and you can solve it and come for the next class. Fine. This molecular mass of water is also 18 grams. So solve this and you can come for the next class. We'll end the session here today. Any doubts?